everyone, welcome to an algebra tutorial video learning about exponential functions. In this last video of the sequence, I wanted to take a little bit of time just to compare and contrast graphs of exponential functions with graphs of linear functions and just point out some of the differences, both obvious, both small, and just make sure you guys are really understanding the differences between these two classes of functions. All right, so here we go. We have two functions over here. So function g of x equals 2 times 1.5 to the x power. This is my exponential function. It has x in the exponent, or my independent variable in the exponent. And we can tell from our pattern it's starting at 2. I'm multiplying 1.5 over and over and over again, so we use an exponent to show repeated multiplication. Well, if g is my exponential function, then f is my linear function in the red over here. So we're starting at a value of 2, similar to the function g, but I'm going to be adding 4 repeatedly. That's why we have plus 4 times x. X just tells us how many times we're repeatedly adding that same amount. Okay, let's start with linear. Linear function in the red here. So all linear functions are always straight lines. So if we're dealing with a linear function, it is always a straight line. That's the whole point of linear growth. We're always adding the same amount over and over and over again. And so the growth rate never changes. That's a steady rate. I'm up, even up here, I'm growing by the same steady adding, even as I did down here. Same adding. So steady growth, straight line, steady growth, constant growth. It can both increase or decrease. In this case, we have an increasing function. The domain is always all real numbers. All numbers. And the range is also all numbers. So there's no limit to this thing in terms of increasing up or going down. Remember, the domain is all the x values. So in a linear function, I can put anything in for x, or I can take any y value and solve for that y value. So the range is also all real numbers. There's no limitations on where this thing goes. Now, exponential functions, on the other hand, are a little bit different. So for exponential functions, just by looking at the graph, most of the time, although they can look like straight lines, they're not straight lines. They are curved lines. Some are more curved than others. In this case, we have a nice curve, so it definitely is showing exponential growth. It's increasing. We have growth, but our growth changes. The growth rate changes. In other words, we can see from here, from 0 to over to 2, I'm growing by a little bit, right? We get up that much in the y values, but then I go another 2, and we get a little bit bigger in the y values. That's a bigger jump right there than it was right there. If I go another 2 for x, wow, we're getting even a bigger jump. So the growth rate changes, and in fact, it increases a lot. Although the linear graph seems to be growing faster, it's higher, it's bigger y values at the beginning, we can see that the exponential function really quickly begins to catch up, is equal to the line right there, but then it's like taking off. It's like increasingly fast growth. And right over here at this value, this is where that function, my exponential function, always grows faster than linear functions if you go far enough. So the exponential growth changes. It often grows faster, always grows faster than linear. Maybe not initially like in this one, but if you go far enough out, it grows faster than linear. And the domain and range are a little bit different. The domain of exponential functions is always all real numbers. So I can always put anything in for x, but we always have to be really careful on the range. Whereas the range in a linear graph is any y values, so it gets negative, it gets positive, all that good stuff. For exponential functions, we always have an asymptote. There's always a long run value that it gets close to but never gets below. So for the range, we need to find, well, what is that asymptote of the function? A lot of times it's just 0. My exponential function will never get below 0. It'll get increasingly close. I can see on my blue line. If I go to the left, it gets really close to 0 right here, but never ever quite reaches it. And so in this particular graph, the range is all positive numbers. So we need to be careful with what that asymptote is, and the ranges of exponential functions are often very different than the ranges of linear functions. But there you go. There's a couple contrasting functions, linear and exponential, and hopefully it really keys in for you on understanding what the differences are. If you look at a graph, being able to tell, is this exponential, is this linear, and being able to explain what the differences are.